Welcome to MyProjectBazaar.com. Let's discuss about the project parallel network file system using authenticated key exchanging protocols. Let's discuss about the project parallel network file system using authenticated key exchange protocol. Abstract. Let's discuss about the abstract. Parallel network file system is a new standard part of network file system version 4.1 standards. Network file system version 4.1 that follow request for commands RFC 5662 is a minor release of a network file system version 4. Network file system version 4.1 does not modify any network file system version 4 features and functionalities. This paper describes an architecture for a secure file system based on network-attached storage that guarantee end-to-end encryption for all user data. We describe the design of this system, focus on the features that allow it to ensure that data is written and read only by the authorized users, even in the face of attacks such as network snooping and physically capture the storage media. In this paper, existing system we use a Kerberos-based parallel network file system protocols. Many of the practical issues faced in implementing robust Kerberos security in a Unix environment can be easier by using a window active directory system. The existing had some drawbacks. It not be feasible to provide store physical security and network protection for all the storage devices. So we propose 3 authenticated key exchange protocols for parallel network file system. It is not an attribute of the data but an arrangement between the server and the client so that can still be accessed via non-parallel network file system and other file access protocol. Parallel network file system benefit workload with many small files or very large files, and it's suitable for a range of HPC types workloads. Data flow diagram. Let's discuss about the data flow diagram. Start the program. Storage device generate the secret key and GSI. GSI key used the Diffie-Hellman algorithm to generate the GSI key. These keys are encrypted and then storage devices ID are attached to sender server. At the same time, the client generate the secret key and GC used the Diffie-Hellman algorithm. GC and GSI are the two prime numbers, and these keys are encrypted and attached with the client ID to send server. The server receives the storage devices message and client message, and then decrypt the keys and storage device resend the keys. User and storage devices ID, Diffie-Hellman keys, GC and GS, and validity time are encrypted to send the storage devices, and then storage devices GSI key and secret key of the client encrypted to send the client. If the client receive the secret key and client receive the secret key and send the request for server. That request message attach the client ID and storage devices ID. The Server validate generate the validity time and send to the client. If the client encrypt the validity time and secret key and the validity period to send storage devices. Storage devices receive that request and check the client ID is valid, and then if valid, and then check the time validity time. If the validity time is valid, encrypt the session, generate the session key and encrypt the session key and validity period to send the receive client. If that user ID is not invalid, and time is invalid, not send the session key, and then display the graph. Graph is used to display the performance of the key generation time, and then client receive the session keys and time. Check the validity time. If the validity time ended, session key not work, and then client resend the keys in phase 1 automatically generate. Otherwise, the client data receive. Otherwise, the client transmit the file in the network. Let's we discuss about the running procedure for the parallel key exchange protocol. Click the F5 function, run the procedure. Here we use the client and server. Server is generate the secret key for the client and intermediate between the server is intermediate between the storage devices and user. Here server is used to exchange the public key and identity for the client, storage devices and user. Here server first user generate the same public key and identity key and encrypted format to send the server. If the server willing to get receive response, the server's key message, so he activated and then send the server user to server the public key and identity. If the public key used for the Diffie-Hellman algorithm used to generate the keys, and then server generate the storage devices ID and secret key to send it to user, so that keys are encrypted and sent to the user. So now the user ready to retrieve the storage devices ID and keys. If that keys are sending and then received keys are validated by the user, so view that key and date and time. If that user enter the ID and their secret key for validating purpose of the key is correct or not. So he entered the user ID and secret key. Here secret key means the password, and then validated to receive the ID keys are displayed. The ID and ID means IDC means client, it means user key, and IDS means server's ID, and secret keys are sent to the particular storage devices. The storage devices retrieve their keys and validated the key is valid and browse the file to send the user. and then check the time between. If the time session key and generated, because if session key is validated in particular time, so that time in between case the users retrieve that files, otherwise the files is expired. So here we generate the session key. That session keys are generated by the validated and analyze the graph format. If the graph is analyzed the existing and proposed system, here we use the PNF as third. So he compared the PNF third and fourth protocols violation. So he increased the proposed system and optimized the cost. Thank you.